be inspired by war strategy. Sun Tzu says, if you know your enemies and you know yourself, you will not be imperiled in 100 battles. So let's look at the application of this war strategy in the context of proactive patent claim drafting. As we all know, patent claims define the scope of protection, and a lot of emphasis had been made in the past about broad claims and trying to get the broadest coverage in a single patent. However, we have to be really careful to not fall into the traps of the common rejections and objections raised with the USPTO. I represent a lot of Indian applicants who seek US patent protection. We are based in Bangalore and we work with a lot of technology companies. One of the concerns they have is like, can they obtain patents in the US related to software? And the other is how soon can they get the patent? So we try to address these issues in this presentation. An optimum patent claim is drafted by knowing the invention as well as knowing the grounds on which the claim is likely to be objected to or rejected. So proactive claim drafting is about being prepared in advance to overcome such rejections. Knowing the invention. In this context, I'm going to talk about avoiding restriction requirements as well as 101 rejections. And how do we do that? One is by focusing on a common solution to one or more problems potentially. And while drafting method claims, to map the steps to structural components that execute the steps. And to satisfy the transformation test, bring out the transformation clearly in the method. When we're talking about knowing the prior art, that helps to avoid 102 and 103 rejections. Draft a claim to ensure that there's at least one new element and emphasize interdependencies and synergies that are not present in the prior art. Now, I'm going to take you through a case study of a software company in Bangalore that we work with. It was for a product called SearchCherry. It's an enterprise solution. So when we're trying to pull out documents in an enterprise, one way to do it is through search, and another way is by a portal which is hierarchical and which has a classification. Now, this product is something that it starts with a search, and it gives you the functionality of a portal dynamically. That enables a user to just, for example, search for a name of a business entity, and through that process, interact with siloed applications or standalone applications directly without having to build a portal. And this is an example of how the screenshot looks. You can just come up with a search, and you get a lot of information, which is like a portal, which is including the financial data, the profile of the business entity, some of the correspondence with the business entity in a single snapshot, which is a dynamically created portal. Okay, now with reference to this example, I'm going to talk about how we complied with 101. One thing we can do is by satisfying the machine or transformation test. For the system claim, we can positively recite hardware components, such as a database stored in a memory, a processor which executes modules, and a display device that displays the actionable portlets that I mentioned earlier. And for the method claim, we can satisfy the requirement of transformation by reciting all the steps involved in transforming an input of one type to an output of a different type. Now let's look at the independent system claim. Just look at the highlighted portions. We have a database, and just by adding these words, stored in a memory, executed by a processor, and displaying on a display device, we can just at least satisfy the examiner to comply with 101. Now, the method claim is a little bit more tricky. We have to satisfy the transformation requirement. So if you see the preamble, it talks about automatically generating a dynamic portal triggered by a search query. So the input here is a search query, and the output is a dynamic portal. The first step is talking about searching index information residing in standalone applications. And the last step is talking about displaying an actionable portlet that enables a user to perform additional operations on those standalone applications. So the input is a one type, which is just a search query, and the output is actually an actionable portlet, which enables further operations on those standalone applications. Thus, it satisfies the machine or transformation test. Now we'll come to restriction requirements. How do you avoid them? If there are multiple embodiments, try to identify the common components or steps and include them in a single independent claim of each type. And you can always put the additional elements for each embodiment in different dependent claims. And try to avoid different limitations in different independent claims. That is if you're really keen on avoiding a restriction requirement. Now, I'm going to take you through another example of two independent system claims that were drafted after discussion with the inventors. The inventors were keen on getting two different embodiments allowed, and we initially drafted two independent claims. Okay, so this was one independent claim where it's both are related to a software-defined radio subsystem, which is capable of supporting multiple communication standards. And one embodiment was that the SDR system was capable of being used for modulation, demodulation, as well as transmodulation. And this is something which we see in the claim. And we drafted another claim, which had similar components, but then there was this limitation that the SDR modem processes the first set of instructions in a transmission mode and a second set of instructions in a receiving mode. Although the components are more or less similar, we have different limitations here, which could potentially lead to a restriction requirement. Now, we drafted a single independent claim covering both the embodiments. We first listed the individual units, which is an SCC unit, SPC unit, and a CCC unit. And we talked about how each of the units are correlated to the other units and what input each one receives from which other unit and the specific output, which is sent to the other unit. And this brought out the functionality. For example, it says that the SCC unit, it receives a baseband signal from the SPC unit, and it produces a digital IF signal for modulation. And the same unit receives an IF signal from a tuner and produces a complex baseband signal for demodulation. So we brought out this aspect of modulation as well as demodulation inside the body of the claim. And we covered those other embodiment, like there was another embodiment for transmodulation in the dependent claim, where we talked about receiving a baseband signal from the SPC unit and producing an IF signal for transmodulation and receiving an IF signal from the tuner and producing a complex baseband signal on a second communication standard. So this brought out the other embodiment of it being applicable for multiple standards. Now we've covered 101 and we've covered restriction requirements. I'll talk a little bit about avoiding a 103 rejection. Now this is something you can do proactively as well when you're drafting the claim. That is, you can analyze the prior art references, which are either provided by the inventor or from a prior art search. And you can split the whole method into parts and map them to the existing prior art, because that's what the examiner is going to do. You can include limitations in each of the steps that are not there in corresponding prior art, and also be prepared with arguments on why the references can't be combined. Now let's look at the same example now in the context of 103. Now here we're looking at a method claim, a method for demodulating an input signal in an SDR subsystem, which is capable of supporting multiple communication standards. So it includes all these steps. Now, there are some highlighted, some parts of this in bold, which talk about how we include certain elements in each of the claim elements, which make it clearly distinguishable from prior art in the context of avoiding 102 as well as 103 rejections. So when we say receiving from a tuner, And then we talk about the output at each step. You're down converting either the IF signal or low IF signal or standard IF signal into a down converted IF signal. And then the next step, there's a filtered complex baseband signal. And we characterize the CPU by saying it's adapted for block-based signal processing. Now, these are some characteristics of these claim elements which enabled us to easily distinguish over the prior art. We looked at two references. Reference 1 was a tuner with tunable analog components that can interface with an SDR. Now, in this reference, a zero IF signal or a low IF signal was received inside the tuner and not from a tuner, because the claim was, the invention, the prior art was about a tuner itself. It was not about an SDR subsystem. The reference 2 was about a processing unit that can implement a software-defined radio, and in that reference, many examples of processing units were given. Here we were prepared with arguments. That reference 1 fails to disclose that an IF signal is received from the tuner, because the IF signal is actually received in the tuner. And the same tuner, although it looks very similar, the examiner cited it because the tuner looked very similar, but that same tuner was not modifiable to give an IF signal as output, because its tunable analog blocks were not software defined as per the claim. And we could always argue that the architecture of the first reference would require implementing a tunable analog complex filter, which would consume a lot of area, power, and there was no teaching, suggestion, or motivation for modifying the tuner in this way. And in reference to the generic processing unit was actually teaching away from the signal processing CPU that we had claimed that was adapted for block-based signal processing. Thus, we could argue that the tuner of reference 1, when combined with the processing unit of reference 2, even when coupled to an additional external SDR subsystem, would consume a lot of power, form factor, and would increase the weight of a wireless system. As we all know, wireless systems have to be less in weight. Thus, the combination is inoperable and practically not realizable. So to conclude finally, claims can be proactively written to minimize objections and rejections from the USPTO, thus resulting in expedited patent grants and also ensuring that the claims are defensible in case of future invalidity proceedings. And once you get the main independent claim allowed, in the first office action, as we did in both the cases, you can choose to argue or pursue broader claims subsequently, knowing well that you're surely going to get a patent issued. Thank you.
Thank you, Arjun. I think that was a